The next topic having to do with confidence intervals will be confidence intervals for population proportions. So we're going back to binomial experiments, which remember have two outcomes that we label the probability of success and the probability of failure. The probability of success in one trial of a binomial experiment is a probability proportion that we can estimate. In some situations, like when you're flipping a coin, you know that the probability of getting heads is 50%, probability of getting tails is 50%. However, if you're conducting a survey, for instance, and your answers are yes and no, the probability of somebody saying yes is not a number we necessarily know in advance. So instead, we can estimate that probability of success with a probability proportion. And the way that we do that is by using a point estimate for P, the population proportion of successes. It's quite simple. It's given by the proportion of successes in a sample. You'll see this little P hat notation, P with what looks like a party hat on it. To determine the population proportion of successes, we're going to take the successes in a sample, which is X, and divide it by the sample size. All we're really doing is calculating the percent of successes in our sample. And that will be our point estimate for success. And then the point estimate for failure, which is Q, is gotten the way we normally get Q, which is to subtract the probability of success from 1. So you'll see Q hat equals 1 minus P hat. This is a relatively simple idea. There's some complicated sounding terminology, but at its heart, you're just finding a percentage. Suppose we have a survey of 1,550 US adults, and 1,054 said that they use the social media website Facebook. Find a point estimate for the population proportion of US adults who use Facebook. So in order to calculate the point estimate, P hat, we just take the number of successes and divide it by the sample size. So the number of successes in this case is people saying they do use Facebook, and there were 1,054 of those out of a total sample of 1,550 people. So again, you're really just finding a basic percentage. If you divide those numbers, you'll get this to be the decimal 0.68, or if we want to write it as a percentage, it's 68%. In other words, that's our estimate for the population proportion of US adults who use Facebook. Next, then, we're going to talk about how we form the confidence interval for a population proportion. So this is the first time, instead of having the population mean be in the center of our interval, we're looking at the population proportion. So we're going to take our point estimate and subtract the margin of error, and take our point estimate and add the margin of error to create the interval. And we have yet another margin of error formula specifically for these binomial probability experiments. And you can see that this formula requires that you know the value of P hat and Q hat. Z sub C is again just the critical Z-score based on what level of confidence you're looking for. And because we're going back to binomial distributions, here's a reminder that we can approximate a binomial distribution with a normal distribution when, and here's the same formulas that we saw before, but now with P hat and Q hat in there. And in that case, the sampling distribution of P hat is approximately normal with the mean of the point estimate for the population proportion of success will just be equal to P. And the standard error, or in other words, the standard deviation for the population proportion of success is given by this formula. And here we have a reminder of what those critical Z-scores are. So going back to example 1, let's construct a 95% confidence interval for the population proportion of US adults who use Facebook. So again, the difference here is we're constructing this interval for the population proportion. which is the letter P. So in our interval, that's what's in the center now. And again, remember it was P hat minus the margin of error and P hat plus the margin of error. So previously we showed that P hat has a value of 68%, and we always use that value as a decimal, so that's 0.68. I'm also going to need the point estimate for the population proportion of failure. If the probability of success is 68%, you do 1 minus the decimal version, 0.68, and you get the probability to be 0.32. And before we go further and use any formulas, we need to double check that n times p hat and n times q hat are both greater than or equal to 5. In our example, remember our sample size was 1,550. So I'm going to take 1,550 times 0.68 and also times 0.32. And you'll get 1,054 for the first value, you'll get 496 for the second value, and the important thing here is that both of these are greater than or equal to 5. So we are allowed to go ahead and calculate the margin of error for the standard normal distribution using capital E equals our critical z-score times the square root of p hat q hat divided by n. Our critical value, remember, if we want our confidence level to be 95% or 0.95, I go back to the table that we just saw a moment ago right here, and my critical z-score is 1.96. So I would substitute that in. So now I have 1.96 times gigantic square root sign. P hat is 0.68. Q hat is 0.32 divided by the sample size, which is 1550. And just make sure that when you calculate the square root on a calculator, you're going to want parentheses around all of this on the inside to make sure it takes the square root of all parts of this. When you do that, you get approximately the decimal 0.023. That's my margin of error. So now I'll go to my p hat, which was 0.68, subtract that amount, and add that amount. So I get a boundary on the left of 0.657 is less than my population proportion of success is less than 0.703. If I was asked to interpret this result, I would say that with 95% confidence, we can say the population proportion of US adults who use Facebook, remember that's what a success was, is between, and remember the p-values are probabilities, they are just percentages. So now I can move the decimal place 2 places over in each of these numbers, and I can say is between 65.7% and 70.3%. And again, the power here is that based on the results that I got in a sample, I'm able to predict the percentage of people who use Facebook in the entire US adult population. So it's this idea of generalizing from a sample to the entire population.